Welcome to Oryx Learning. Today's lesson is on Unit 7, Transformations, Lesson 2, Reflections. Ozma is painting a picture of a flower and wants it to be perfectly symmetrical. She has painted the first half and labeled 2 points, A and B. Ozma now needs to know where to paint A' and B' so that the second half is symmetrical. If you'd like to find the answer to this question, please follow along and we'll revisit it at the end. A reflection is the result of a transformation of a figure over a line called the line of reflection. In the reflection, the image is congruent to the preimage, as each point of the preimage and its image are the same distance from the line of reflection. As we can see here, triangle ABC is reflected over a vertical line, in this case the y-axis. When reflecting over the y-axis, the points xy become negative x, y, negating the x values. So as you can see here, point A is at 1, 4. If I negate only the x value, that becomes A', or negative 1, 4. Point B, which is at 2, 0, negating the x value, becomes negative 2, 0 for B'. And point C, which was at 4, 2, negating the x value, becomes negative 4, 2 for C'. I can also reflect over the horizontal axis, the x-axis, and those points, xy, will become x negative y, negating just the y value. So as you can see in the original triangle again, ABC, point A is at 1, 4. 1, 4, if I just negate the y value, will become 1, negative 4 for A'. Point B at 2, 0, if I negate the y value, stays at 2, 0, as the negation of 0 is 0. And point C, which is at 4, 2, negating just the y value, will become 4, negative 2 for C'. A reflection is a mirror image of the original figure. A reflection is the result of a transformation of a figure over a line called the line of reflection. In a reflection, the image is congruent to the preimage, as each point of the preimage and its image are the same distance from the line of reflection. So as we can see here, figure ABC is reflected over the x-axis to create the figure A', B', C'. The point A and A' are the same distance from the line of reflection, as is the point B and B', and C and C', creating two congruent figures. If we would like to reflect a figure over the x-axis, multiply the y-coordinate by negative 1. So the coordinate xy becomes x negative y. Here's an example of two figures reflected over the x-axis. In order to reflect a figure over the y-axis, multiply the x-coordinate by negative 1. So a coordinate xy would become negative x, y. And here's an example of two figures reflected over the y-axis. The image below is reflected over which axis? The x-axis, y-axis, both, or neither? So as we can see on the image, point AB and the point A negative B. So in this case, the y value was multiplied by a negative 1 from B to negative B. Therefore, we know that the symmetry is x-axis symmetry. The figure is reflected over the y-axis. Find the coordinates of point A' and B'. If we're reflecting over the y-axis, we know that the point xy will become negative xy. So if we take a look at point A, which is originally negative 1, negative 3, if we multiply the x value by negative 1 times negative 1 becomes 1. so A prime would be the point 1, negative 3. Point B originally is negative 2, 0. If I multiply the x value by a negative 1, negative 2 times negative 1 is 2, so B prime becomes the point 2, 0. This allows me to finish the graph, which becomes a butterfly. Graph the reflection over the x-axis of the figure below. When reflecting over the x-axis, the point xy becomes x, negative y, where the x-coordinate stays the same and the y-coordinate becomes negated. If we look at our first point, point A, which is at 1, 1, negating the y value, that will give us the point 1, negative 1. If we look at point B, which is at 4, 2, keeping the x value the same and negating the y value will give us the point 4, negative 2. And point C, which is at 9, 3, if we negate the y value, will become 9, negative 3. So we can see that point A reflects to point D, point B reflects to point E, and point C reflects to point F. Now all we need to do is to connect our dots, and there we have it, the reflection over the x-axis of the original figure. The following pre-image is reflected over the blank to create the image. So if we look at figure ABC, we can see from A, B, C to A prime, B prime, C prime, the x values are negated or multiplied by negative 1. If the x values are multiplied by negative 1, from A, 1, 3, we get A prime, negative 1, 3. From B, 5, 2, we get B prime, negative 5, 2. And C, 4, negative 1, becomes C prime, negative 4, negative 1. This means that xy became negative xy. The x was multiplied by a negative 1. So the following preimage was reflected over the y-axis. A landscaper is hired to build beautiful flower gardens on either side of a driveway. The first triangular bed is built, and he wants to create an exact reflection on the other side of the driveway. Given that the driveway is the x-axis in the diagram, find the coordinates of D, E, and F and plot them on the graph. When reflecting over the x-axis, the x value of the coordinate stays the same and the y value is negated, so xy would become x negative y. So if we look at point A on our graph, A is the point negative 2, 1. Keeping the x value the same and negating the y value, that would give us the point negative 2, negative 1. So that will be point D, negative 2, negative 1. Point B is up here at 1, 4. Keeping the x value the same and negating the y value gives us 1, negative 4. And point C is at 3, 2. 3, 2 negating the y value would become 3, negative 2. Let's connect our vertices with our line segments, finishing off the triangle. So from D to E, E to F, and from F back to D. So we can see that there's two triangular gardens, one on each side of the driveway, reflections of each other. Back to our painting. Ozma is painting a picture of a flower and wants it to be perfectly symmetrical. She has painted the first half and labeled 2 points A and B. Ozma now needs to know where to paint A prime and B prime, so the second half is symmetrical. Y-axis symmetry, the coordinate xy becomes negative xy, multiplying the x value by a negative 1. So for our point 0, 5 for A, multiplying the x by a negative 1 will still give us 0, 5. For the original point B, 2, 4, if I multiply the x value by a negative 1, I will get B prime, negative 2, 4. So the coordinates that she needs to paint are for A prime, 0, 5, and B prime, negative 2, 4. So remember, a reflection is a mirror image of the original figure. If I would like to reflect over the x-axis, I need to multiply the y-coordinate by negative 1 xy becomes x negative y. And if I want to reflect over the y-axis, I need to multiply the x-coordinate by -1, making xy negative xy. And here are some examples of each. I hope you enjoyed the lesson. Thank you for watching.